Hi, I'm Uno Wennergren, and today I'm going to give a talk to you. But a friend asked me the other day, what are you actually going to talk about? And then I started to think, what is the one-liner of this talk? And my answer was, everything goes to hell. Can you actually say that? Well, I think you can. And for example, the United Nations, the Secretary General, Guterres, said 2022 that we are on a highway to climate hell in full speed. And the other problem we also have was that in November last year, 2024, the international panel of scientists that are studying the change of biodiversity concluded that we are actually have lost during the last 50 years 70% of the populations of animals on the globe. So we're actually on two highways, one to climate hell and the other one towards a biodiversity nature hell. And I will put the forest and agriculture into this kind of problem. And I will also, as Guterres said, show you the exit ramps from these highways. But I also want to mention one more thing that makes it even more problematic, is that these two highways, that is the path towards climate hell and the path towards biodiversity hell, are actually enhancing each other and makes a perfect storm. A perfect storm that could actually sweep over the globe and make a lot of problems. But there are exit ramps. Remember that. Okay, let's take a look at the background a little bit. And what we actually have, we have the climate change, we have the species extinctions, but on top of that, we also actually have today a fair amount of hunger and poverty. And that part is also a process that have a large effect on the problem of climate change and loss of biodiversity. Before we dive into that, we need another part of the background. And that is that we use resources. That's why we're actually losing species and we have this climate change, because we use energy and we also have a lot of land use for products from forests and food from agriculture. Well, if we become even more people, then we will use even more resources. So let's take a look at population growth so we get an idea. Because say that we, for example, reduce our resource use today with 30%, but the population increases even more than 30%, then we haven't actually used less resources from the globe. So let's take a look. Here you can see the population growth during the last 12,000 years. And as you can see, extremely steep, straight up during the last couple of hundred years. So we're moving from the 800s, when we were around 1800s, we were around 1 billion, and today we are 8 billions, and there's a projection towards 10 billions 25 years from now, and then it slows down and we will probably reach somewhere around 11, 12 billion people. And today we are 8 billions. And have that in mind during this talk, because how we use the resources is very much related to how many we are and what will happen in the future. a little bit of idea of this. So during the 1800s, 1820, almost like 10% on the globe, on the 1 billion people, had a fairly wealthy life, while 90% had hunger and poverty. Today, on the other hand, it's the reverse in the percentage part. That is, only 10% has a poverty and hunger problem. So it looks like we are having a better situation on the globe. But percentage is problematic, because if you can see here from the 1990s, these are the amount of people living in extreme poverty, and we have actually been able to reduce it from the 2 billion people down to a little bit less than 1 billion. As you can see, it's leveling off, and we're actually putting ourselves around 800 million people in poverty, which is almost the same numbers as you saw on the previous slide in the 1820. So we're about approximately the same amount of people under hunger and poverty at that time. Also, note, in the bottom here, you can see the sub-Saharan Africa, and there we have an increase of people being in extreme poverty and hunger. Now, we should switch towards look a little bit on the climate change problem. Today, we are facing extreme events on the weather. We have flooding, etc. We are around 1.5 degrees increase since the 1800s. And you should also know that the level of greenhouse gases today is the same as when we had kind of a heat period a couple of million years ago, with an increase of something like 3 degrees in warmer and 20 meters higher sea levels. Then the levels of emissions were at the same level as we have today. There is a kind of a time lag, because the seas and the ice are still cooling it off compared to what we will be when we have an equilibrium. What's actually been happening? So these are the annual carbon dioxide emissions from fuel from 1959 until 2024. And you can see we have a continuous increase, almost linear, and it's pointing straight up. So we can't really see any direct change. And here you can see how the temperature have increased since the 1800s until today, and it's just pointing straight up. So we don't, if you look at the numbers and don't listen to words, what we're actually is towards, as the General Secretary said, towards climate hell. If you look a little bit from a history perspective and a little more on details, because it's good to know these things, will have a large impact on forest, on forestry, on food production, and how we use our land. Here you can see to your left what kind of different energies, when we consume energy, where do they come from? To some extent, it's coming from nuclear, hydroelectricity, and then we have the fossil ones, and we also have the biofuel at the bottom. If you look a little bit on like a projection towards 2060, you can see it on your right hand, you can see that we expect the solar panels to increase and become like 50% or more of our energy production. Note, percentage. So even though the fossil ones are decreasing, as you can see on the right panel, the growth of our energy use could be such, and if you're really studying it, it will be almost the same amount of fossil energy as today, but it will be a less proportion of the total energy, but the emissions will stay the same unless we do something else. And also, going back to forestry a little bit more, here you have two graphs. And the idea with these two graphs is what happened with forests. Will we have less or more when we try to beat the climate change? To your left in the B figure, you will see here we have a carbon tax on fossil energy and industry, as well on land use, that is bioenergy, you could say. On your right, we don't put any carbon tax on the land use, a little bit like we're actually doing today. And you could see at the end of this century, it will be almost the same proportions used, and we're having the same amount of nature forests, managed forests, unmanaged pastures, etc. But if we don't put a carbon tax on bioenergy, the bioenergy crops will become a cheap way of getting energy. And you could see that we will lose a lot of our forests that we have today. Hence, what kind of energy that we make expensive and cheap will have a large effect on the forests of tomorrow. And then we have another thing that's actually interacting with this. If you look at this graph, you could see, okay, we have the fossil fuels to the right, and if you use fossil fuels, well, then we get greenhouse gas emissions into the atmospheric pool of carbon. If we use what's on the left side, which is the vegetation, if we burn down forests or use bioenergy, we will move carbon from your left towards the atmospheric pole. And then the photosynthesis will take some of it back to the biosphere again, to the vegetation. Also note that this carbon may take the route down to the soil, and there it will decompose, and the carbon dioxide will get into the atmospheric pole. That route instead. And some of it will also go to the oceanic pole, etc. But the big thing is what's the equilibrium, given how we use our land, between the two pools to the left, the biotic pool and the pool in our soils of carbon. How are they equilibrium between these two and the atmospheric pool? Are we feeding the atmospheric pool with carbon dioxide? Well, before that, we need to think a little bit about land use and forestry and agriculture. Because if we use our land for agriculture, we cut down our trees, and instead we'll have agriculture, then we will have less of vegetation standing there. You can think of it a little bit like this. If you go into a forest, you will see all the trees, and all the trees have carbon in them. But if you instead go to an area where you grow oat, wheat, or something, you of course realize it's less carbon there. So what you're actually doing is you're moving the carbon that previously was in the trees up to the atmosphere. It's the same when you do a clear cut. But the route for that, what you take out from the forest, is a slower path until it reaches, you could build a house or something, and then it will take longer time. But the land use is really important. So let's take a look on the land use and how that combines and have large effect, both on the carbon that's in the vegetation, and also a little bit on how do we change these things with regards to biodiversity. We need to know how is the land used on our globe. First of all, we need to understand primary succession. What is that? Primary succession is, say that you have a bare land, bare rock. Actually, I was studying on Mount St. Helens after eruption from that volcano. There you start with the primary succession. It's completely like a desert in some way. And then the lichens come, the mosses come, the grass comes. And the vegetation slowly evolves into different phases, and it reaches what one usually calls a climax community. And you could see here that in the middle you have the grasses and perennials, which is a little bit like our fields when we grow wheat or something. And then we move into grasses and shrubs, and we get trees, and then we get more shade-tolerant trees such as oak and hickory. And this is kind of the root how things evolves. And you could also see how the soil becomes a large and large proportion. And if you can, of course, realize we have much more carbon to the right in the vegetation than the soil than to the left. And here you can think of it, if I have a managed forest, what are we actually doing? Well, we're actually moving, when you make a clear cut, from the right to the left, and then it moves back up towards the right again, but not really as a ordinary succession, because we have decided that the trees should be of the same age and the same species. So it's a little bit different. But have this in mind as an idea of what we're actually doing. And if we make agriculture, we move it back towards the grasses and the perennials in the very middle, and let it stay there all the time. And it's also there, one species, one age, all the time. Okay, how are the land use actually looking? Well, at the Earth's surface, 29% of the surface is land. 71% of that is habitable, which means that you could have there could be some vegetation there. Some other things are like barren land, glaciers, etc. Of that proportion that's habitable, half is agriculture today. If we humans shouldn't have been there, it shouldn't be nothing of that should be agriculture. It should be like ordinary grasslands, like natural ones, or forests. 37% of the habitable land are forests. And also take a look to the left, what happens with their agricultural land? How is it used? How much of that is used for livestock, for meat and dairy? How much is used for crops? How much of the meat are used for our calorie supply? Well, most of the calorie supply on the globe is from the plant-based food. How much of the protein is from the meat? Well, most is from the plant-based. So you could say that even though 77% of the agricultural land is used for livestock, it doesn't actually give us 77% of our calorie or protein. Here you can see how much forest we have lost over the time. I won't dive too much into this picture. I think you could look at it afterwards and look, because there are a lot of text. And in general, what you have is a zero line, and below it you have the loss, and above you have the gain. And you can see we have gained a little bit in the temperate regions. We have gained a little bit and get more forest than we had before. But if you look at the tropical forest, we're just losing all the time. And you could see that a lot of this have happened during the 1900s and today. And the losses are mainly for agriculture and to produce food. Okay, now you may start to think, okay, we need food. Yeah, I know. The exit ramps are not that we all should be hungry and be in poverty. It's actually only slight changes and will make a big difference. Okay, forests. Here you can see how the forests are distributed on the globe. Where are forests where you can see that they are actually management, that is what sometimes you call it like secondary forests, and also where do you have old growth. And you could dive into this and see, but a lot of this, the dark green are the ones where we haven't had any effect on the forests, and the other ones we are managing. And you can see that most of the forests on the globe are managed. Okay, we discussed a little bit on the carbon. There are more carbon if we have a forest compared to if we have agricultural land, which means that we're actually moving carbon and enhancing the climate change if we change from forest to agricultural land, but also if we change from old growth to secondary forests, that is managed forests. And to the left here you can see how much is the potential biomass stock compared to when we actually manage them. For example, the crop land, bottom to the left, at the bottom, the yellow ones, you could see if we go all the way up and meet the line that goes on in the middle, you could see that we could actually have almost 10 kilos per square meter, 10 kilos of carbon. But today it's almost no carbon in the biomass. So that's how much we have lost. And you can also see that if we are managing forests, we lose approximately 3 kilos per square meter compared to old growth. And to your right, you could see what are actually how much of the carbon loss from the surface of the globe are related to use tropical forests. That's when we have secondary forests in the tropics. If we have it in other forests, if we're actually making croplands, etc. And you could see the yellow also here, the yellow ones are when we have made a conversion from natural habitats into cropland or for grazing. So how much is this? Here you can see from 1850 until today how much of the greenhouse gas emission comes from our fossil fuels, and in the green you can see how much is from the land use and forestry. And actually these numbers have actually changed over time. We learn more and more. It's kind of hard to go back and realize how much was it in 1850, how much did we have then, etc. The important thing is to see we did lose a lot of carbon to the atmosphere during the 1800s from turning things into cropland and by forestry. And that also happened before 1850. In general, today you say, okay, what we have in the atmosphere, 2/3 are from the fossil fuel and 1/3 is from the land use. But it's actually good that it's so much from the land use. It gives us an exit ramp. Okay, biodiversity losses. We have to put this in this perspective as well. Well, biodiversity, as I said before, we have just now got the report that we have lost 70% of the animal populations. They have reduced by 70%. It means that, for example, when I was a teenager, if we had like a population of 100 eagles, today, 50 years later, there are only 30 individuals in that population. It's kind of a mean for how much the population have been reduced. And they have mainly been reduced because of the land use. So how is that? Well, the species is depending on resources. So it depends on what vegetation you have there, what are the other species there, and not only on one plant, for example. They usually need one plant to feed on, something else to hide in, and something else that gives you opportunity to actually find a mate, for example, which could be good. And this is very much related to the primary succession, as I showed you before. And of course, to the very right, you have a very diverse ecosystem with a lot of different species that can thrive on different kind of vegetation. If you go into a forest, you will of course realize everything doesn't look as to the right, because we have some kind of climate or other kind of restrictions on whether the forest actually could situate and actually thrive in that area. It could be too wet, too dry, too cold, too warm, too dark, or something. And that's what's happened in a forest. Oh, here it becomes wet and we don't have that much of trees. Or we come into that area, well, usually when you don't have trees, you actually have the grasses and the shrubs. And then, for example, it could be moss or something. So have this one picture around in your head. And of course, since we have used 50% of the habitable land for agriculture, we use most of the forest as for forestry. We have lost a lot of species. So this is the drive and what makes our lose the species, and it also makes us lose a lot of carbon to the atmosphere. So this is kind of the two highways towards the two hells. Okay, soon we're going to look at the exit ramps. Here, you just can see how we have lost the species, and this is from the report this fall 2024. There are some components to this that we need. If you remember, I said in the beginning, it's very much related also to hunger and poverty. So there are some kind of geographic and society components into this. Okay, I put all these figures in this slide. To the left top, you can see where the hunger is most prevalent. And you should also have back in your minds that China managed to move out from being a hunger and poverty during the last 25, 30 years. But you can see the sub-Saharan problem there. You have the big yield gaps at the same place where you have the hunger, which means that you could actually increase the yields there if you had a proper way, an effective way of farming there. You can also see where we lose the forests also in these areas. And it's also in these areas, right bottom, where we have the largest population growth. Well, they actually say at the end of this century, given the population growth we have today, that we will have 40% of the population on the globe will actually live in Africa, because that's where we have the growth of populations. And if we don't manage to handle the poverty and the hunger, we will lose even more forests, and we'll lose even more carbon to the atmosphere. One important thing, if we turn into forest here, 50% of what we take out from forests are used for bioenergy. So if we could instead turn this around and not use forests products of what we take from the forest to energy, we could actually reduce what we take out from the forest by 50%. Okay, we have to restructure the industry, etc. But there is a great potential there. If we go to Africa, 90% of what we take from the forest goes for cooking and heating. And then when we have this that you're looking at in front of you, you realize there is a large problem. Okay, exit ramps. Before we finish this, I won't make a big talk about that, but I think you all can realize there are actually exit ramps. But we have to make some kind of change to get off from these highways towards the two hells in front of us. First of all, we need more forests, because if we really make a big change here, we will get back a lot of the wild populations that we lost during the last 50 years. And how can we get more forest? Well, we can use less land for food production. And we need to do that. By effective farming, we could actually use only 50% of the area of today, and we get the same amount of wheat or whatever. So there's a really nice study about this. And there are also studies that shows if we all turn vegetarians, if we turn to become a vegetarian, you will use less than 50% of the area. You probably remember how much of the protein and calories that we actually got from crops versus from meat. And a very recent study, just a few weeks old, showed that if you use bioreactors to produce bacterial proteins, you need a specific amount of energy for that. And if that comes from solar panel, you will actually get 32 tons of proteins per hectare, while soybeans only gives you 1 to 2 tons of protein per hectare. So there is a huge potential there as well to reduce the land we have for food production. And as I said before, no forestry for energy. 50% of the forest raw materials is for energy, and 90% in Africa. So if we actually are able to not do, as I showed you in the very beginnings, have used bioenergy to a large extent, instead we need to tax that and had other solutions as solar panels or whatever, but not fossil and not bioenergy. Increase the recycling of forest products. One have recently shown that you could actually recycle paper, well, at least 25 times if you look at the chemical structure of it. There is a saying of 4 times, but that's not correct if you look at the chemistry. And of course, turn the tap off for fossil energy as soon as possible. And we also need to fight hunger and poverty. If you get some numbers on this, if you don't use forests for energy, we will have 50% less raw material that are used. So we could actually rewild 50% of our forests. That's 8 years of global emissions. If you become vegetarians and turn farmland into wild forests, by the years and centuries, it will become old growth. That's almost 50 years of global emissions. If you do bioreactors instead for our protein production, we will have 32 tons per hectare. And if we would use the solar panel to produce all the protein we need, even those that today don't get the right amount actually got their amount, we only need to use 0.1% on today's farmland of solar, and put solar panels on them and then produce the bacterial protein. So there is a great potential, and there are absolutely exit ramps that will give us a large proportion of carbon sequestration, and we will stop the loss of biodiversity. So we shouldn't take the wrong way. We shouldn't enter and go along that highway, because if we stay on that highway, we'll enter a perfect storm, and we don't want that. It will be actually pretty bad. Instead, we should take the exit and rewild, and also remember we should have the wetlands, and also natural grasslands. So there is a solution to stay on the right track. Thank you for watching.